Hi, I'm Johnson. Again, I have come up with a new results. The limits of sin x over x when x approaching 0 is equal to 1. We all know that the result is always is equal to 1. And here we use a direct substitution. As we replace x with 0, what is our numerator? When sin 0 is going to be 0 and using x equal to 0 for the denominator, again we get 0. So 0 over 0 indicates that it has no value. It leads us into indeterminate form. So then in what way we can prove this result? One of the way to prove this results, we could use a squeeze theorem to proving this results. And now let's come to the point. What is squeeze theorem? Let's say we have a function f of x and which is bounded between two other functions. Let's say h of x as well as g of x. If this function is bounded between two other functions, then this bounded function are same in value, then the middle function f of x is also going to be the same. Like if we have a value of 7 to the both extremes, then it is not going to be 6 or 8 because that cannot satisfy this inequalities. So it has to be 7 only. So this is squeeze theorem. We apply this inequality, the squeeze theorem, to find this results. Now, I need to know what is h of x and what is g of x and what is f of x. And I'm going to define h of x. So how do I define this? Let's take a unit circle. So this is x-axis and this is y-axis. I just take a unit circle. It's a 1 unit circle and the radius is 1. To define this function, I draw a tangent. We all know what is tangent. A tangent is a straight line which touches the curve at a point. And I'm connecting these two extremes. Now what I have got, I have come up with a right angle triangle. Since it is a tangent line meeting radius at a particular point, we can have an angle of 90 degree here. Opposite to 90 is called hypotenuse. If we have an angle here, then opposite to this angle is opposite side. Since it is y-axis, let's call this length as y. And this length let's have as x-axis. This is x. You know, it is a 1 unit circle. So the length of x is also 1. Since it is a radius of the circle, so x is going to be 1. Now I need to know the ratio of tan theta. What is tan theta? The ratio of tan theta is opposite by adjacent. What is my opposite here? My opposite I have is y. My adjacent I have x. It is a 1 unit circle and the radius is 1. So x replaces with 1. So since it is going to be 1 on the denominator, I need not write. So I have got y. What is my y? Y here I have got is as tan theta. So this length of a triangle, of a side of a triangle is tan theta. To define this h of x, I need to have the area of this right angle triangle. So I just get the area of a right angle triangle. What is the formula for finding the right angle triangle? So the formula for finding the right angle triangle is 1 by 2 BH. Our base here is 1 since it is radius x and our height is tan theta. So what is our base is 1. 1 by 2 times 1 times tan theta. So now what is the area of triangle? The area of triangle is tan theta divided by theta. So tan theta by 2 is my function of h of x. So now I have defined the function h of x as tan theta divided by 2. So what is my h of x is tan theta divided by 2. Next, I need to define the next function f of x. But seeing this inequality, f of x needs to be smaller than h of x. So again I am going to have a 1 unit circle, but this time I am going to have a sector which could be the smaller shape of the right angle triangle. So that is the justification of inequalities here. Okay, so if I have a sector here, this is going to be a smaller shape than the right angle triangle. So my h of x is a right angle area of the right angle triangle, and my f of x is going to be the area of a sector. So again it is an angle which is included angle with its two sides. So what is the one of its side as radius? It's 1. Again this side is again 1. So both the sides we have radius. To find this area of the sector, I use this formula. Area of sector is theta by 360 degree times by r square. What is my by? By. So by is 180 degree. If I replace by with 180 degree, I can cancel this. 1 times 180 in here, 2 times it is 360. So now what is remaining? R square. R square, I have r is a length of one of the sides of a sector, so which is 1, because it is the radius of a 1 unit circle. So it's going to be 1. So since it is 1, so what is the leftover I have is the area of the sector is theta by 2. So here I use the area of the sector which is theta by 2. So this could be my function of f of x. So f of x is theta by 2. Now I need to define g of x. To define this, again I am going to take 1 unit circle. But in the inequality, g of x is smaller than f of x. So g of x needs to be a smaller shapes of f of x, which means we have a sector as a f of x, and smaller than the sector could be, we can have as an isosceles triangle. An isosceles triangle, let me select an isosceles triangle. See, what is my sector? My sector is slightly greater than my isosceles triangle here. See, this is my sector and this is my isosceles triangle, which is less than the sector. Then my g of x is going to be smaller than the function f of x. So I am going to use an isosceles triangle as my g of x. So I need to know what is the area of an isosceles triangle. So an area of an isosceles triangle, area of a triangle, I am going to use this formula to find an area of an isosceles triangle, because if I take this is an angle, this is an included angle with two of its sides. If one of its side is A, the other side is B, then this is the formula for finding this isosceles triangle. So the formula is 1 by 2 AB sin theta. What is A here? What is B here? A is 1, B is 1, since it is a 1 unit circle, and A is going to be equal to the radius of this circle. So what is my area of an isosceles triangle is just replacing A with 1, B with 1. I have left out with sin theta divided by 2. That's my area of an isosceles triangle. So this is my function of g of x. So g of x is sin theta divided by 2. Now I have defined all the functions what is in the inequalities. H of x is tan theta divided by 2, f of x is theta by 2, g of x is sin theta by 2. Now let's plug in g of x, h of x, f of x into the inequalities. What is my g of x? My g of x here is sin x over x, which is less than or equal to, okay, what's my f of x? My f of x is x over 2, which is less than or equal to, what's my h of x? My h of x is tan x over 2. So I need to use limits as x tends to 0 to all the functions. So if I'm using limits of sin x over x as x approaching 0, which is less than or equal to the limits of x over 2 as x approaching 0, again the limits of tan x over 2 as x approaching 0. I'm sorry, here it is 2. Now what we have, can we notice that the denominator of all the functions are common or same? So we can get rid of the common denominator. So as we multiply 2 to all the functions, the 2 will be cancelled out. Okay. So what is the remaining is limit as x approaching 0 of sin x less than or equal to limits of x as x approaching 0. And finally, what was the left over here is limits of tan x as x approaching 0. So I have cancelled out all the 2 since it is common in all the function. Okay. Now, in order to get this, what we can do is we can also divide every function by sin x. Okay. So if I divide here by sin x, what I get, sin x over sin x less than or equal to, here we have a limits, okay, x over sin x less than or equal to limits tan x over sin x. Sin x over sin x is going to be 1 less than or equal to, we have limits also, limits as x approaching 0, and here sin x, x over sin x, limits as x approaching 0 of x over sin x, again less than or equal to limits as x approaching 0 tan x by sin x. What is tan x by sin x? Tan x is sin x by cos x, again we have over sin x. So what can we do now? We can cancel here, and what is the remaining here is 1 over cos x is the leftover function. Okay, so now we are clear with the all the functions. Now it has to be, this has to be in a form of reciprocal. Okay, it has to be in an inverted way. X by sin x needs to be sin x by x. So we take a reciprocal. Okay, we invert this. So if we take reciprocal, as we apply reciprocal to the inequalities, the sign of inequalities changes. Okay, when it is less than or, it becomes greater than or equal. Okay, so as I am applying reciprocal here, it is just 1, and if I apply reciprocal, so what I get, sin x over x, again if I get reciprocal here, it is going to be cos x. Okay, use the limit also everywhere. Now it's all clear, but we rewrite this inequalities. Okay, I just bring cos x to the front as a first function, then sin x over x, and I push back there. I'm just rewriting, not changing any sign. So I'm just rewriting. So how do I rewrite? Cos x, we use the limit also, limit as x approaching 0. The symbol is cos x is the greater than the function, so it is greater. And sin x, we use the limit also, limit as x approaching 0, sin x over x, which is greater than or equal to limits as x approaching 0, 1. So now we directly plug in 0 to all the x. So if we replace x with 0, what is cos 0? Cos 0 is 1, which is greater than or equal to the limit of x approaching 0, sin x over x. If we directly plug in 0 for the constant, we get again 1, because the limit of any constant is constant. So that is 1. Okay. So now the squeeze theorem is satisfied. The bounded functions are same with their values. Therefore, the mid function is also going to be the same value. Okay. So what is the limit function we have? The limit of sin x over x as x approaching 0 is equal to 1. Okay, this is our limit. I hope this is very useful for you, and I request you to subscribe my channel and learn things, never stop learning things. Thank you.